The National Electrical Code, specifically Section 210.11 C3, addresses the requirements for bathroom branch circuits. It's important to understand these requirements to ensure safe and compliant electrical installations in bathrooms. Let's break down the two scenarios presented. Firstly, if you run a dedicated 20 amp 120 volt circuit to a bathroom receptacle outlet, which must be ground fault circuit interrupter protected, you can extend that circuit to supply other bathroom receptacle outlets. The key here is that you cannot connect any other types of outlets to this circuit, such as lighting outlets, exhaust fan outlets, or heater outlets. This dedicated circuit is solely for supplying receptacle outlets in multiple bathrooms. Secondly, if a single 20 amp circuit, again with ground fault circuit interrupter protection, serves only one bathroom, then you are permitted to connect other loads within that bathroom to that same circuit. This means you can supply lighting outlets, exhaust fan outlets, and even heater outlets, in addition to the receptacle outlet, all from that single 20 amp circuit, as long as it only serves that one bathroom. These two scenarios are distinct and depend on whether the circuit serves multiple bathrooms or just one. The reasoning behind these rules is primarily for safety and to prevent overloading of circuits. Bathrooms often have multiple high-demand appliances, such as hair dryers and curling irons, plugged into receptacle outlets. By limiting the connection of other types of loads to the receptacle outlet circuit when it serves multiple bathrooms, the risk of overloading the circuit is reduced. In the case of a single bathroom, the code allows for more flexibility, assuming that the total load within that one bathroom will still be within the capacity of the 20 amp circuit. It's crucial to always calculate the total load on any circuit to ensure that it does not exceed 80% of the circuit's rating as required by the NEC. For a 20 amp circuit, this means the continuous load should not exceed 16 amps. Continuous load is defined as a load that operates for 3 hours or more. When calculating the load, include all connected devices and appliances and use their rated wattage or amperage to determine the total load. Remember to consult the specific requirements of your local electrical code, as local amendments may exist. Additionally, it's always recommended to consult with a qualified electrician for any electrical work to ensure compliance with all applicable codes and regulations. Now let's delve deeper into the practical implications and considerations for these bathroom circuit wiring rules. When running a dedicated 20 amp circuit to multiple bathrooms for receptacle outlets, it's important to use the correct wire gauge. According to the NEC, for a 20 amp circuit, you typically need to use number 12 American wire gauge copper wire. However, always consult the ampacity tables in the NEC, such as table 310.15 B16, to verify the appropriate wire size based on the insulation type and installation conditions. Ensure that all connections are made properly and securely using appropriate connectors and devices. Loose or corroded connections can cause overheating and potentially lead to a fire hazard. When installing ground fault circuit interrupter protection, be sure to follow the manufacturer's instructions carefully. Ground fault circuit interrupters are designed to protect against electrical shock by detecting even small leakage currents. They should be tested regularly to ensure proper operation. In the case of a single bathroom circuit serving all loads, carefully consider the types and sizes of the loads that will be connected. Lighting fixtures, exhaust fans, and heaters all draw current, and their combined load must not exceed the circuit's capacity. For example, a typical bathroom heater may draw 10 to 12 amps, while a lighting fixture may draw 1 or 2 amps. An exhaust fan may draw less than 1 amp. Adapt the amperage of all these devices to determine the total load. If the total load is close to 16 amps, it may be prudent to install a separate circuit for the heater or other high-demand appliances. This will help prevent nuisance tripping of the circuit breaker and ensure that all devices operate properly. Another important consideration is the placement of receptacle outlets in bathrooms. The NEC requires that at least one receptacle outlet be located within 3 feet of each basin. This receptacle outlet must also be ground fault circuit interrupter protected. Additional receptacle outlets may be desired for convenience, but they must also comply with the NEC requirements. When wiring bathroom circuits, always use appropriate wiring methods such as non-metallic sheath cable or conduit, depending on the specific requirements of your local electrical code and the installation conditions. Ensure that all wiring is properly supported and protected from physical damage. When running wiring through walls and ceilings, be sure to follow the NEC requirements for fire stopping and draft stopping. This will help prevent the spread of fire in the event of an electrical fault. It's also important to properly ground all electrical devices and equipment in the bathroom. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Use appropriate grounding conductors and connectors, and ensure that all grounding connections are made properly and securely. Finally, remember that electrical work can be dangerous if not performed properly. If you are not comfortable working with electricity, it's always best to hire a qualified electrician to do the work for you. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in compliance with all applicable codes and regulations. Let's elaborate further on the implications of the NEC requirements for bathroom circuits. The code's intention is to ensure safety and prevent overloads, which can lead to fires or other electrical hazards. The differentiation between multiple bathrooms and a single bathroom served by a 20 amp ground fault circuit interrupter protected circuit is a key aspect. When a single 20 amp circuit supplies multiple bathrooms, the restriction on connecting lighting, exhaust fans, or heaters is in place to dedicate the circuit's capacity primarily to receptacle outlets. This is because receptacle outlets in bathrooms are often used for high wattage appliances like hair dryers, curling irons, and electric razors. These appliances can draw a significant amount of current, and if other loads are connected to the same circuit, it could easily become overloaded. In contrast, when a single bathroom is served by a 20 amp circuit, the code allows for the connection of lighting, exhaust fans, and heaters because it's assumed that the total load within that single bathroom will be more manageable. However, it's still crucial to calculate the total load to ensure that it doesn't exceed the circuit's capacity. When calculating the load, consider the following factors. Firstly, the wattage of all lighting fixtures. This information can usually be found on the fixture itself or in the manufacturer's specifications. Secondly, the wattage of the exhaust fan. Again, this information should be readily available. Thirdly, the wattage of any heaters. Bathroom heaters can range in wattage from a few hundred watts to over 1000 watts, so it's important to know the exact wattage of the heater you are using. Fourthly, the amperage of any appliances that will be plugged into the receptacle outlets. This information can usually be found in the appliance itself or in the manufacturer's specifications. Once you have gathered all of this information, you can calculate the total load in the circuit. To do this, add up the wattage of all of the lighting fixtures, exhaust, fan, and heater. Then, divide the total wattage by the voltage of the circuit, which is typically 120 volts, to get the amperage. Finally, add the amperage of any appliances that will be plugged into the receptacle outlets. The resulting number is the total load on the circuit in amps. As mentioned earlier, the total load should not exceed 80% of the circuit's rating, which is 16 amps for a 20 amp circuit. If the total load is close to or exceeds 16 amps, you should consider installing a separate circuit for the heater or other high-demand appliances. It's also important to consider the type of wire used for the circuit. As mentioned earlier, number 12 American wire gauge copper wire is typically required for a 20 amp circuit. However, it's always best to consult the ampacity tables in the NEC to verify the appropriate wire size based on the insulation type and installation condition. The ampacity of a wire is the amount of current that it can safely carry. The ampacity of a wire depends on several factors, including the wire size, the insulation type, and the ambient temperature. The NEC provides ampacity tables that list the ampacity of various types of wires under different conditions. When installing wiring in bathrooms, it's important to use appropriate wiring methods such as non-metallic sheath cable or conduit. Non-metallic sheath cable, also known as Romex, is a type of electrical cable that consists of two or more insulated conductors enclosed in a non-metallic sheath. Conduit is a type of tubing that is used to protect and route electrical wiring. The choice between non-metallic sheathed cable and conduit depends on the specific requirements of your local electrical code and the installation conditions. In some cases, conduit may be required in bathrooms to provide additional protection for the wiring. When running wiring through walls and ceilings, it's important to follow the NEC requirements for fire stopping and draft stopping. Fire stopping is the process of sealing openings in walls and ceilings to prevent the spread of fire. Draft stopping is the process of sealing openings to prevent the movement of air, which can also help to prevent the spread of fire. The NEC requires that all openings around electrical wiring be fire stopped and draft stopped using approved materials. It's also important to properly ground all electrical devices and equipment in the bathroom. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. All metal parts of electrical devices and equipment, such as metal boxes and metal enclosures, must be grounded. Grounding is typically accomplished by connecting a grounding conductor to the metal part and then connecting the grounding conductor to the grounding system of the building. Finally, remember that electrical work can be dangerous if not performed properly. If you are not comfortable working with electricity, it's always best to hire a qualified electrician to do the work for you. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in compliance with all applicable codes and regulations. In summary, understanding and adhering to the National Electrical Code's requirements for bathroom circuits is crucial for ensuring electrical safety. The key takeaway is the distinction between circuits serving multiple bathrooms versus a single bathroom, particularly regarding the allowance of connecting lighting, exhaust fans, and heaters. Always calculate the total load, use appropriate wiring methods, and prioritize safety by consulting with a qualified electrician when needed.